Today we are going to learn how to find the transfer function from Bode plot. Transfer function from Bode plot. Directly let us solve on sum. For the Bode plot shown in figure, find the transfer function. Find the transfer function. This is the answer. This is the answer for given sum. How to find this transfer function from the, this is the answer. How to find the transfer function for a given Bode plot. We know that we will form a table to draw the Bode plot. We have to reverse the table. Reverse the table. The first step is there. Finally, we will write coordinate. Instead of that, here we will write the range. The range of frequencies. Then net slope. We are writing the reverse order. Then slope of slope by the factor. Then we have to write the corner frequency. We are writing in the reverse order. Then we have to write the factor. So this is the way by which we have to find. The range of frequency is, let us call, this is omega 1. Here, another corner frequency, that is omega 2. This is another corner frequency, omega 3. This is omega 4. That's all. This, here, the value is 0.1, it is given. At this corner frequency, omega 2 is not given, but the magnitude is given. In this corner frequency, the corner frequency is given 8 and the magnitude is not given. Here, the magnitude is given, but corner frequency is not given. For this, we have to find the transfer function. The first thing is, if it is a slope, negative slope, then that too its slope is minus 20 dB per decade, means it is K by S. If it is horizontal, means K only, that we know. If positive slope means with 20 dB per decade, means Ks. So these are all we know. So here 20 dB per decade, the slope is 20 dB per decade. The frequency range is from omega 1 to omega 2. The net slope is minus 20 dB per decade. dB per decade. This is also dB per decade. Minus 20. This is also slope by the factor is minus 20. No corner frequency. Initially, there is a slope. That's why it is K by 20 dB. That's why K by S. Minus 20 dB. That's why K by S. The next one is omega 2 to omega 3. Here, omega 2 to omega 3, the slope is minus 40 dB. Net slope is minus 40 dB. Earlier it is minus 20. Now it becomes minus 40, means the slope by the factor is minus 20. And it is minus 20. The corner frequency is omega 2. Corner frequency is omega 2. Therefore, T2 equal to tau 2 equal to 1 by omega 2. Therefore, the factor is negative slope with corner frequency. Therefore, 1 by T2s plus 1. So this is also over. The next one is omega 3 to omega 4. Omega 3 is here. It is given 8. The slope is changed from minus 40 to minus 20. The net slope is minus, in this range, minus 20. Earlier it is minus 40, now it becomes minus 20 means plus 20 dB. The corner frequency is omega 3. Therefore, T3 equal to 1 by omega 3. Therefore, this is numerator factor plus 20. Therefore, T3s plus 1. That is also. Now, omega 4 to infinity. So, what is the slope? Minus 40. So, it's changed from minus 20 to minus 40. It is changed from minus 20 to minus 40. Therefore, minus 20 is the slope given by the factor. Therefore, the corner frequency is omega 4. Corner frequency is omega 4. T4 equal to 1 by omega 4. Therefore, it is negative. That's why 1 by T4 is plus 1. That's the question is now reduced to finding K, finding T2, finding T3, and finding T4. That's all. If you find K, T2, T3, T4, we can form the transfer function. How to find K? At omega 2, we do not know the frequency, but here we know at omega 1, we know the frequency, but we do not know the magnitude. Here we do not know the magnitude. That's why it's not possible to find at 0.1. We do not know the magnitude. Magnitude we know at omega 2. That's why first we have to find the omega 2. First we have to find the omega 2. To find omega 2, what we can do is, for this what we will write is y2 equal to slope. This is the formula. Log omega 2 by omega 1 plus y1. This is the formula that we used to use. So if you use that formula, what is y2? Y2 is what is omega 1 and omega 2 we'll use, and here we do not know the magnitude. Here we do not know the magnitude. Here we do not know the frequency. Therefore, we know one straight line, but two unknown. That's why we cannot use that. That's why we cannot use that. But here, one more point is given. Here, one more point is given. The frequency is 0.4. No, see the diagram. The frequency is given as 4. At that point, what is the magnitude? Magnitude at this point is 0 dB. That is given. Therefore, instead of using this line, we can use this line. Line A is no use because two unknowns. Here magnitude is not known. Here frequency is not known. That's why we cannot use that line. But this line, here we know the magnitude 0, frequency is 4. Both points here we know. Here we know the magnitude, we do not know the frequency. That's why that we can find. So suppose this is omega 1, this is omega 1, this is omega 2, like that if you think. So y2 equal to 0. 0 equal to slope. What is the slope here of this line? Minus 40. Minus 40. Log omega 2 is 4. Omega 1 we do not know. 4 by omega 1. Omega 2. 4 by omega 2. 4 this point we know, but here the frequency is omega 2. Omega 2 plus y1. What is the magnitude here? 36. 36 that we know. Therefore, we can say that minus 36 divided by minus 40 equal to log 4 by omega 2, or 36 by 40 equal to 4 by omega 2. 4 by omega 2 equal to 4 divided by omega 2 equal to, this becomes positive because both negative, that's why it becomes positive. 4 by omega 2 equal to 10 to 4 by omega 2 equal to 10 to the power 36 by 40. If you use that 36 by 40, then omega 2 equal to 0.5. Omega 2 equal to, this implies omega 2 equal to 0.5. Therefore, we can substitute here omega 2 equal to 0.5. Omega 2 equal to 0.5 means T2 equal to 1 by 0.5 is 2. T2 equal to 2. Now, at omega 1, at omega 2, this is up to omega 2. This slope is up to omega 2. Now we know omega 2 is 0.5 and the magnitude also we know. Therefore, for this we can write 20 log k by omega 2. That is omega 2 is what? 0.5. 0.5 equal to 36. Therefore, k equal to, so what is k? From this k we can write k by 0.5 equal to 10 to the power 36 divided by 20. Therefore, k equal to 31.55. Therefore, k equal to 31.55. That's all. So we found two parameters. Now we have to find the third parameter, T3. Here, omega 3 we have to find. Omega 3 equal to what? For that, if you use omega 2, now we know both values. Omega 2 equal to what? Omega 2 equal to 0.5. Therefore, y2 equal to 36. Omega 3 equal to what? At omega 3, do you know magnitude? We do not know the magnitude. But omega 3 equal to 8 is given. 8 is given. Therefore, omega 3 equal to 8. Omega 3 equal to 8. Therefore, y3 equal to what? Y3 equal to what? Y3 is required. Omega 3 is equal to 8 means, omega 3 equal to 8 means T3 equal to 1 by 8. That is T3 equal to 0.125. 0.125. This also over. This also over. But we need y3 because to find omega 4 we need this value. We need this value. That's why let us find y3. Y3 is the old value. Therefore, what y2 we know all. Therefore, y3 equal to slope. What is the slope of this line? Minus 40 dB. Minus 40 log omega 3 is 8, omega 2 is 4, not 4.5. 0.5. Omega 2 is 0.5. 0.58 divided by 0.5 plus there the value is 36. If you use this, what we'll get? y3 equal to minus 12. Minus 12. y3 equal to minus 12. Minus 12. Now we know y3. y3 equal to minus 12. Therefore, here already we found this. Now we have to go for this range. We can go for this range. Omega 4 we have to find. The slope is minus 20 dB per decade. Here, the 8 comma minus 12 is the coordinate. Here, the coordinate is omega 4 comma minus 21. So omega 4 we have to find. Therefore, minus 21 equal to what is the slope? Slope is minus 20 log omega 4 not known. Omega 3 is 8 plus what is that slope? Magnitude is minus 12. So minus 21 minus 12 equal to minus 9. So minus 9 equal to minus 20 log omega 4 by 8. This implies minus minus getting cancelled. Therefore, 9 by 20 equal to log omega 4 divided by 8, or omega 4 by 8 equal to 10 to the power 9 by 20. This implies omega 4 equal to omega 4 equal to 22.55. Omega 4 equal to 22.55. So omega 4 equal to 22.55. Therefore, T4 equal to 1 by omega 4. T4 equal to 1 by 22.55 equal to 0.04. Therefore, T4 equal to 0.04. So we found all parameters. So we got the transfer function. What is K equal to 31.55? That is 31.55. Here T2 is the T3 is 0.125. That's why we got the numerator factor. Here this is 2. This is 0.044 and S in the denominator. Yes, we got all factors. This way we can find the transfer function. So we have to reverse the table. That's all. Another example. Find the transfer function of the Bode plot shown in figure. Here G of S is given. This is the answer. Answer is this. We have to find this. So again, we have to form the table. Range, net slope, then slope, corner frequency, then factor. So these are all. So now range is for first. This is this is omega 1. This is omega naught. Okay, let it be omega naught, omega 1, omega 2, omega 3, omega 4. Omega naught is 0.25. Omega naught and magnitude is 0.25. Here the range is omega naught to omega 1. Omega 1. What is the slope? The slope is 12 dB per octave. Already I told you that 6 dB per octave equal to 20 dB per decade. Here it is 12, therefore it is 40 dB. The slope is a positive slope, therefore 40 dB per decade. This is also dB per decade. 40 dB plus 40. Therefore, what is the net slope? Plus 40. What is corner frequency? No. Ks square. So 40, that's why Ks square. Numerator is square because slope is positive. That's all. Then omega 1 to omega 2. Omega 1 to omega 2. In omega 1, omega naught is given 0.25. 0.25. And omega 1 also given 0.5. Omega 2 is given. Omega 2 is given 1. Omega 2 is given 1. Omega 3 also given. Omega 3 also given 2. Omega 1 is 1. Omega 3 is 2. Omega 2 is 1. Omega 1 is 0.5. Omega 1 is 0.5. So what is the slope? Slope is changed from 12 dB to 6 dB, reduced. That's why it is changed from 20 dB per decade. 12 dB means 40 dB per decade, which corresponds to what? 12 dB per decade. To how much reduced? 6 dB per decade. In other words, it reduced to 20 dB per decade. So it means what? Positive value reduced means some negative value came. So the new net slope is 20 dB per decade plus dB per decade. So it means what? There is a contribution by the factor is minus 20. That's why it reduced from minus 40 to 20. What is the corner frequency? The corner frequency is omega 1. Omega 1 equal to 0.5. Corner frequency is 0.5. Therefore, T1 equal to 1 by 0.5 equal to 2. The factor is negative, therefore 1 by 2s plus 1. 1 by 2s plus 1. So next one is from 2 to omega 3. Omega 3. Omega 2 to omega 3, it becomes 0. Net slope is 0. Net slope is 0. Already it is plus 20. It becomes 0 means the contribution is minus 20. Therefore, omega 2, the corner frequency equal to omega 2 equal to what? It is given in the diagram 1. Therefore, T2 equal to 1. T2 equal to 1. Therefore, the factor is minus, contribution is minus 20. Therefore, 1 by T2 is 1, S plus 1. The factor is S plus 1. Here, the factor is 1 by T1 S plus 1. Here, 1 by T2 S plus 1. T1 is 2, T2 is 1. So, next range is omega 3 to omega 4. Omega 3 to omega 3 to omega 4. Here, it reduced to minus 6 dB per octave. Therefore, minus 0 to minus 6 dB. 6 dB means minus 20 dB. Therefore, the net becomes minus 20. 0 becomes minus 20 means the contribution is minus 20. Therefore, omega 3 equal to, it is given, that is 2. That is 2. Therefore, 1 by 2 equal to T3 equal to 1 by 2 equal to 0.5. Therefore, the factor is 1 by 0.5 S plus 1. 1 by 0.5 S plus 1. After that, no frequency response. That's why we cannot write anything. The only thing is we got this factor. We got this factor, this factor, this factor. So all the three factors we got. The only thing is we have to find K. To find K, either at omega naught or omega 1, we need the magnitude. At any one place, we need the magnitude. But magnitude is not given. But we can find the magnitude. At what is the 0.25 here? 0.5 here, 1. The slope is 6 dB per decade. So here 30 means it increases at the rate of 6 dB per decade, means here what is the value? 24 dB. 24 dB here. Here 0.5, here 0.25. 1 octave. This distance is 1 octave. 1 octave. 1 octave. 1 octave, it decreases at the rate of 6 dB per decade. Therefore, 30 minus 6, 24. Here 24. Here also 1 octave. 2 octave. 2 octave. 12 we have to subtract. Therefore, here 12 dB. 12 dB. So we know the values. From that we can find. Let us use omega 1 to find K. 20 log modulus of K S square. That is equal to that is equal to 20 log k omega square equal to 24, where omega equal to 0.5. Therefore, we will get 24 divided by 20 equal to log k multiplied by 0.5 square, 0.5 omega square, 0.5 square. Therefore, log k 0.5 square equal to k 0.5 whole square equal to 10 to the power 24 by 20. Therefore, k equal to 63.1. K equal to 63.1. K equal to 63.1. So that's all. So we got the value. So now we can write, combine all these things, we get the transfer function g of s equal to 63.1 s square upon 2s plus 1 s plus 1 0.5 s plus 1. Yes, we got the answer. Suppose you are given an instrument, an amplifier, it may be an amplifier or some instrument. For that, you are required to find the transfer function by experimental way. How we can find? We have to find the frequency response for this. This is the magnitude response. Magnitude response. The table is given. Frequency omega equal to 0.1, 0.2, 0.3, etc. up to 35 is taken. For that, the magnitude in dB is given. The following frequency response test data were obtained for the forward path elements of a unity feedback control system. Plot the data on a semi-log paper and determine the transfer function of the forward path. So if you draw this on a semi-log sheet, it will be looking like this. The black is the magnitude plot. Now we need asymptotic plot, Bode plot. Asymptotic plot is required to find the transfer function. Therefore, we have to draw the asymptotes for this graph. If you draw an asymptote, this is the asymptote. This is the asymptote. This is the this dotted line is the asymptote. Asymptote. The slope of that asymptote is minus 20 dB per decade. And the corner frequency, again, draw the asymptote for this part. So the asymptote should pass through maximum part of the graph. Like that, you have to draw the tangent. That's all. So here, this covers the first asymptote covers asymptote plot covers this much area. Here also, this covers this much area. This much area. So if we draw a line, this is the asymptote. This is the asymptote. This is the asymptote. Asymptote. Second asymptote. Third asymptote, for this part, you have to draw a horizontal line. So now the plot becomes like this. The dotted line is the asymptotic plot. We know the corner frequency. The first asymptote and second, first asymptote plot and second asymptote plot meet at the 0.5. That is the corner frequency 1, omega 1. One corner frequency we got. What is the slope here? The slope of this line is minus 40 dB per decade. The change in slope is minus 20 dB. So now we'll here this minus 40 dB becomes 0. Here it becomes 0 dB. 0 dB per decade. That's all. Now we will form the we will find the transfer function. The transfer function is here. It is written. We know that it has one S because initial it is not horizontal, it is inclined at minus 20 dB. Therefore, K by S, and one denominator first order factor because it has minus 20 dB slope here. Because of that, here the change is 40 dB. Here the change is 40 dB. That's why there is a possibility of second order factor or repeated poles. We have to find whether it is second order factor or repeated poles. How to find that, we'll see. Now we have to form the table to find the transfer function. The first range is omega naught to omega 1. This is omega naught to omega 1. Range is omega naught to omega 1. Omega naught is 0.1. 0.1 here. This is 0.5. Then net slope is given. That is minus 20 dB per decade. Slope is dB per decade. This is also dB per decade. Minus 20 dB. Again, this is minus 20 dB. Initially, they are slope. That's why corner frequency, no corner frequency. The factor is minus 20 dB. That's why K by S. We have to find the K. Factor is K by S. The next one is slope is changed from omega 1 to omega 2. Omega 2 is where? Here. This is omega 2. Omega 2 is 4.4. Omega 2 is 4.4 from 0.5 to 4.4. The slope is minus 40. The change is minus 20. Therefore, corner frequency is omega 1, that is 0.5. Omega 1 equal to 0.5. Therefore, T1 equal to 1 by 0.5, that is 2. The factor is negative slope, that's why 1 by T1 S plus 1, that is 1 by 2 S plus 1. We got one factor. The next one is 4.4 to infinity. That is omega 2 to infinity. 4.4 to infinity. At 4.4 to infinity is 0. Therefore, it is contributed by the factor contributes plus 40. Then only it becomes 0, because earlier it is minus 40. Now it becomes 0, means plus 40. Therefore, omega 2 equal to 4.4 from the diagram. But 40 dB means there are two possibilities. It may be a repeated poles or second order factor. To find that here we see that the corner frequency is here. The corner frequency is here. True plot is here. This is black is the true plot. True plot. The gap is about 5 dB. 5 dB. Minus 5 dB. The gap is minus 5 dB. So asymptotic plot minus actual plot, you will give the error minus 5 dB. The error is negative. That's why it is over-damped system. That's why repeated factor. Over-damped or critically damped system. Damped part. It is not zeta value is not there. That's why it is repeated. That's why we can write 1 by T2. T2 equal to T2 square. 1 by T2 S plus 1 whole square. In the numerator, because plus 40. It is in the numerator. T2 S plus 1 whole square. T2 equal to 1 by T2 square equal to 1 by 4.4. Therefore, T2 equal to square root of 4.4. square root of T4 equal to square root of 1 by 4.4, that is equal to 0.227. So 1 divided by 4.4. If we take square root of this equal to repeated poles 2.27. Omega 2 is 2.27. Yes. 1 by 1 divided by 4.4 equal to 0.227. Yes, repeated pole. It is not equal to 1 by 4.4. That is 1 by 4.4. That is equal to 0.227. Therefore, 0.227 s plus 1 whole square. Why repeated poles? Because the error is negative. More than about 6 dB. Error means it is repeated poles. That's all. Therefore, the transfer function is g of s equal to whether we got k not yet for me. So we cannot write. We have to find k. We got T1, T2. The only thing is we have to find k. To find k, we need two values. Here we know two values. Here, this is 30. This is 40 means 31, 32, 33. At omega naught, the magnitude is, at omega naught, magnitude is 33. So that can be used to find k. How we can find 20 log k by omega equal to 33. Therefore, log k by omega equal to 10 power 33 divided by 20. Omega equal to 0.1. Therefore, k by omega equal to 10 power 33 by 20. K by 0.1 equal to 33 by 20 equal to 33. So 10 power 33 divided by 20. Therefore, k equal to, this gives k value. K is equal to 4.5. K equal to 4.5. 4.5. So k also we know that is equal to 4.5 divided by s. So we got the transfer function. This is the first slope. That's why 1 by s. If first is horizontal line means k only. This is k by s. K by s. If positive slope means ks. You extend that first slope till it intersects 0 dB line. This is the 0 dB line. This is the 0 dB line. The first slope is extended. Extend first slope till it intersects with the 0 dB line, x-axis. It intersects at 4.5. So we can find that way also k equal to 4.5. That way also you can find k. Therefore, the transfer function is 4.5, that is k divided by s, and numerator we have 0.227. 0.227 s 227 s plus 1 whole square divided by 2s plus 1 multiplied by 2s plus 1. That's all. That's all. Yes. We got the same answer. Therefore, the given transfer function is this. This is the given. This is the transfer function for the given Bode plot, frequency response. So how to find? Draw the frequency response, then make it a asymptotic plot, approximate plot by drawing tangents so that it covers most of the points. We got 3 segments. For the 3 segments, we got 3 components. That's all. Another example. Here also frequency response is given. Frequency response is given. Frequency response is given. For that, this is the answer for that frequency response. Here we have drawn that this dark line is the magnitude plot. Then we are drawing the asymptotes. The first slope extended till intersects with the 0 dB line, so that we can find it directly k, that is k equal to 200. K equal to 200. The slope here is minus 20 dB per decade. Initial slope, not horizontal line, therefore k by s. The first factor is k by s. The next one is it becomes horizontal. The corner frequency is 0.9. The corner frequency omega 1 equal to 0.9. The slope becomes minus 20 to 0. Therefore, numerator factor. Therefore, omega 1 equal to 0.9 means 1 by 0.9. 1 by numerator factor 1 by 0.9 s plus 1. Why numerator factor? Minus 20 becomes 0. This becomes 0 dB per decade. This is second factor. This is first factor, second factor, numerator factor. Then third factor. Third factor, again it becomes minus 20 dB. 0 becomes minus 20 dB. Corner frequency is 9. 9. Therefore, 1 divided by 1 by 9 s plus 1. So that is third factor. Then fourth factor, here minus 40 dB. Minus 20 becomes minus 20 means another first order factor. The corner frequency is 110. Therefore, 1 by 110 s plus 1. That's all. So 1 by 0.9, 1 by 9, 1 by 110 s plus 1. These are the factors. Then 1 by 0.9 is 1.11. 1 by 0.9 is 0.111. 1 by 110 is 0.009. So we got the transfer function.